So, you want to build a device that will let you walk in any of your games and works with your regular keyboard? Fantastic! By the end of this video, you will know where to buy the parts, how to put them together, and a few assembly tricks for the best end result. Let's get started. Go and grab an Arduino Leonardo, USB host shield, rotary encoder, 3D printed parts, power supply, USB data cable, glue gun, glue, screwdriver, Allen keys, zip ties, the pedals themselves, and we're ready to begin. Step 1 is, of course, opening this thing up. Loosen and then remove the tensioning knob using an Allen key. Next, we will want these side screws removed and plastic panels slid out. Yes, both sides. The whole top shell should now pull off pretty easily. With this magnet facing away from you, place the plastic gear into the wheel. Hot glue around the edge to keep it in place, and then squeeze it down flat while it dries. A little more glue on top can help make sure this doesn't come off later. Give the wheel a quick check, it needs to be able to spin freely. Moving over to the rotary encoder now, fix it to the mounting brackets using the included bolts. Slide on the smaller gear and once again apply hot glue. In this next part, you want to find a distance where the gears are nice and close, but not so tight they bind up. Once you find this, hot glue into place. You can always peel it off and try again if you get it wrong. The pedal should still be able to rotate, and the small gear will now move accordingly. This part gets a bit messy, but we're going to glue the cable down onto the strap to keep it out the way. Once dried, feed the cable through the opening in the top shell. Grabbing the electronics case, we can now prepare the wires. Removing some of the outer shielding will give us longer wires to work with. You should make them a bit longer than I do here, aim for a good 15 centimeters. It will make things much easier later. There is a small hole on the underside of the electronics box. You want to feed the whole wire through this until you reach the shielded part. Hot glue this down to the middle as I do. Once dried, separate the thin wires into pairs. Red and black go to the left, green and white go through the right. A small dot of hot glue can help hold them flat here. Now, grabbing your Arduino Leonardo board, insert the metal ends of the wires into the pins as shown on the wiring diagram on screen. To then hold these inside, connect the USB host shield on top. If your wires were cut long enough earlier, you should now be able to slide the stack of boards into the electronics box. Expect some fiddling and poking around of the wires to get a good fit. You will know everything is in place when the ports line up with the holes out the front. The electronics box fits into the hole on the top shell where it can then be glued in place. Next, place a small dot of glue behind the circuit board and while it's hot, press down on the lid. This will stop the boards pushing out the back whenever you're plugging in your wires. The inside of the outer shell is hard to glue onto, so you will need to roughen it up first. Once prepped, glue the cable down to the side here. See how it is out the way and touching the wall inside the outer shell. This is not a very strong glued connection, but does hold everything in place before we zip tie it later. Try and copy the positioning shown in the video. Use more glue to hold the cable alongside the inside frame so it does not touch the wheel. Do this on the side with the magnet facing you. Placing the top shell back on the lower, you will notice an excess of cabling out the bottom. This can be folded over itself and zip tied to the base. Don't worry, it won't touch the floor while we're using it. I like to hot glue it first to hold the wires in position, then put on my zip ties. From here, all we need to do is replace the plastic sides, replace the tensioning knob, and give everything a quick physical test. Moving over to the PC now, insert the data cable into the micro USB port of the Arduino, plugging the other end into the PC. We'll then need to install the Arduino IDE and get a copy of the code. The latest version can be found on my GitHub, and links to everything else will be in the description. Once the Arduino IDE is installed, head to the Boards Manager and ensure the Leonardo board has been added. Next, in the Library Manager, install this USB host shield library. All the other libraries we need are pre-installed on the Leonardo. Depending on the game you're using it with, you will need to adjust some variables. If your game uses shift to sprint, then set sprint on press to true. If shift is used for walk, set this variable to false. Different walk, sprint, and stop sprinting values will feel better for different games. Check the descriptions for the values I use and leave a comment with what works best for you. If you pedal above the walk speed, your character will start to move slowly, above the sprint speed, and they will move quickly until the speed drops below the stop sprint speed. To make sure this works as intended, you will also need to enable hold to sprint in your in-game settings. Now that we're ready, upload to the board as shown. Each time you wish to use the pedals with your game, start up your PC as normal. Before launching your game, plug in the data cable, then move the keyboard cable from the PC to the pedals. If you have any issues getting it to work from this point, you can try connecting an external power supply. Quick troubleshooting, hit the reset button, not accessible at the moment but I plan to update the design, or unplug all the cables and try again in the following order. I hope you enjoyed building this system together. I would love to see some of your units in action and hear any improvements and feedback you've got down below. If you haven't seen the full project video yet, do check it out and get subscribed so you can be the first to the next one. Goodbye.